Our next step after graphing polynomial equations is going to be solving polynomial equations. So if you look at a set here of these three different equations of polynomials, the first one we should be very familiar with. We just go ahead and solve a linear equation in all of our traditional methods. Then we can look at a quadratic equation here, our second one, x squared minus 5x plus 11 equals 0. And we could solve that by factoring if possible, completing the square root method, or quadratic formula. We've spent a bunch of time with those as well, so that should be something we feel hopefully comfortable with there. Now our third equation here is going to be a cubic. When you look at our cubic equation, that one we don't really know how to solve yet. So over the next couple of days we're going to go through the process here of how are we going to solve a cubic equation, and we'll move into quartics and possibly even solving quintics throughout this process. We're going to look at this specific cubic function that we just had on the previous page, x cubed minus 3x squared minus 10x plus 24 equals 0. And to start this process, I'm going to go ahead and just give you one of the solutions to this equation. So I'm going to tell you x equals 4 is one of your answers to this. And based on what we did with our graphing, we should recognize that a cubic function can have up to 3 zeros, so therefore we should get up to 3 solutions for our cubic function. So if I tell you x equals 4 is a solution, that means I could solve this equation equal to 0, x equals 4, by minusing 4 over to the other side, and I get x minus 4 equals 0. And what that means is x minus 4 is something that can be factored out, or it is a factor of my original function. And so if we know that something is a factor of the function, or if we know that something can be divided evenly into something, that means we could divide our original function by x minus 4 to put it into factored form. Just like when you solve a quadratic, it's easiest to factor it and then set each equation individually equal to 0. So I know x minus 4 is a factor of this equation, which means that if I divide x minus 4 out of x cubed minus 3x squared minus 10x plus 24, it has to go in evenly. So to do that, I'm going to go ahead and do synthetic division, just like what we did in our polynomials unit, where if you look here on the right side, I plugged in a 4 because it's always the opposite of the sign in factored form, or it's the solution of x equals 4, it was what goes in our box, and we carry down the coefficients for each term. Then we go ahead and carry down the 1 times 4, add down, times 4, add down, times 4, add down, and that gives us our no remainders situation. So we took this, and you notice the arrow here, and I knew x minus 4 was a factor of my original function. So I can rewrite my original function as x minus 4 times x squared plus x minus 6. So here I have that form of the equation. Just like what we did when we factored a quadratic. If I have a parenthesis times a parenthesis equal to 0, I can set them individually equal to 0. So the x minus 4 gave us a solution of 4, which is what was given to us to begin with. My second parenthesis is x squared plus x minus 6 equals 0. So I have to solve that quadratic equation now. In this form, it can be factored. I can come up with numbers that multiply to negative 6 and add to 1. Those are 3 and negative 2. Giving me my solutions, x equals negative 3 and x equals 2. The type of factoring we're doing here, with the x squared plus x minus 6 is the exact same concept we used above when we said I have a parenthesis times a parenthesis, so I can split them into 2 separate equations. Then I did it again to get my other 2 solutions. So those are the 3 solutions to this equation. If you would graph this in your calculator, again, we're trying to make connections between our equations and our graph. We're looking where it equals 0, so if you used your calculator to find the zeros of this function, they would be at 4, negative 3, and 2. Let's look at one more example. Our original equation is x cubed minus 4x squared minus 16x plus 15 equals 0. Now, because we don't know how to solve a cubic right now, I've given you one solution of x equals -3. Because we know -3 is a solution, we know we can divide out x plus 3 from this cubic, turning it into a quadratic. So in order to do that, we plug -3 into our little box, and we write our coefficients. Then we multiply. Carry down the 1 times -3, so on and so on. And we end up with this as our factored form of our cubic, x plus 3 times x squared minus 7x plus 5. Because it's equal to 0, I can write each parenthesis equal to 0 individually. X plus 3 equals 0, x squared minus 7x plus 5 equals 0. And now I've got myself to two equations that I can solve. X plus 3 equals 0 gets us our original function of our original solution that was given to us of x equals -3. And because x squared minus 7x plus 5 can't be factored, I go ahead and plug into my quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a. The inside of my parentheses works out to 29, which cannot be simplified. So therefore, my second pair of solutions is x equals 7 plus radical 29 over 2 and 7 minus radical 29 over 2. So we're just using synthetic division and factoring in order to solve a cubic function. Good luck. If you have questions, make sure you ask.